Server-side request forgery, a very popular but often misunderstood vulnerability. Many bug bounty hunters hunt for this vulnerability regularly, but many of them fail to escalate on it because they fail to actually understand the mechanics of the vulnerability itself. And in this video, my aim is to show you how this vulnerability works and make sure that whenever you report it, you get the highest possible bounty each and every time. As always, I'll start with the high-level overview of what this bug is, and then I'll jump into the code and some real demo examples so that you can actually see how it works in real life. So we'll start off with what is server-side request forgery. So server-side request forgery is when we can basically trick the server into making requests on our behalf. And the reason this is the problem is explained in this following diagram right here, right? So in websites, this entire bit on the left here would be one server. And the website is just going to be a small part of that which the user can actually access. It's the part of the server which is going to be exposed to the public. And where between the website and the user sits normally some kind of firewall or some WAF, which stands for Web Application Firewall. This basically prevents the user from accessing the other internal services here. So this website hosted here on say port 80 and 443, and then there will always be internal services like a database, an API, and maybe some other service like an internal service or whatever. And these will not be accessible to the user. And it's a job of the firewall to regulate that. But the website will be able to send requests to those services, right? So what server-side request forgery is basically us being able to access these services here by using the server as a proxy for ourselves. And this is usually a problem because where the website often has a lot of security checks, it's often tested very often, these backend services tend to be very vulnerable, tend to use weak passwords, they tend to have like IDOR vulnerabilities in the case of APIs, or they tend to just be open and basically trust the server blindly to not have malicious payloads or anything like that. So if we could get the server to send whatever request we want to on our behalf, and then also ideally return the response to us, we'd be able to interact with these services and find vulnerabilities in them and basically leak files or whatever. So what server-side request forgery is just being able to basically get around this firewall. That's good. What are some of the common things we can find with server-side request forgery? The main thing is website metadata. So usually websites are hosted on some kind of service. So Amazon AWS is an example of this. And the other kind of common one is Google Cloud Service as well here. And these services will have credentials behind them. So that basically just allows the developers to access the server, like configure it, see what's on it and stuff like that. And it's hosted in these internal services. So it's hosted behind here, so behind the server. So a user wouldn't be able to access this, right? But if we can find a server-side request for a forgery vulnerability, we could basically make a request to this metadata, leak it, and then log into the website. That would obviously be a very high vulnerability because we could take the website down, look at the entire source code and stuff like that. So companies want to protect this metadata. And this is kind of what a lot of people look for when they do server-side request forgery. And it's gotten a little bit harder to find it because companies have started hardening this and making it more difficult for hackers to access it. But with the proper headers and stuff like that, you can still do it. Other things we can do is attack internal APIs. As I mentioned before, they're usually not very secured. So if we can like find a way to leak like user data, if we can find a way to basically like modify data or whatever, or like read emails, then that's something that we can do here. And the last kind of main thing is attacking files. So basically if we can use the file protocol or basically find a way to read files off the server, we can convince the server to return some of its local files. And common example of this might be something like etc/password. and like etc hosts or whatever, right? So these files, they're not like malicious in themselves. A hacker might not be able to do much with them, but it kind of indicates that we can access files off the server, so we could enumerate it, basically steal user data, find kind of credentials on the server, usually stored in like a .environment file, and other things like that. So that's the main thing we can do with server-side request forgery. So I hope now you know what it is. And now that I've explained that, I want to hop into the demo example and show you how it looks like in the code. So this is a demo example that I just have set up on my bug bounty website here. And we see here ssrf.php. And here we're missing a URL parameter. So let's see what happens. We'll put a URL down, something like this. We'll say, just try Google Doc. Actually, we'll say example.com, like so. See here, we have what it seems like a returned request. We see the request headers here, and we see the example domain. So it seems like the server has made a request to that domain and has returned the response to us, as we can see. Okay, so now let's see how that looks like in the HTTP proxy. Right? We'll just come here, I'll show this to you. We'll just forward that request there, intercept it, I mean, grab it here, and grab it here again. So you can follow along with this actually if you want to. Then we can go here and basically look at this in the replay tab. So you can see here that we have basically made this request and the server has actually returned the whole headers. Unlikely to see this, to be honest, but I've just included it in the example, right? So what happens if you put an invalid URL? It seems like it's using curl to get the requests, which is interesting. So the first thing you want to test in a kind of SSRF situation right here is to see if you can access the local host. So the local host is stored at 127.0.0.1. This is the IP of your computer, like as you're sending requests from your computer. So this is something that works on every single server and computer. And using this, you should be able to basically send like a kind of like a looping request. You're going to send a request out and it's going to come back to your computer basically. That's kind of how it works, I think. So in this case, we get an empty reply because it seems like there's nothing hosted on this main directory, which is pretty common because most servers now sit on ports. So back then it used to just be port 80 was like the main one, but nowadays, usually if you watch my microservices video, I actually go into this in a lot more detail. But websites are kind of broken down into different services and most of them have a different port, and port 80 is generally just reserved for the reverse proxy nowadays. So when you have a situation like this where you can actually send a request to localhost, first thing I would do now is initiate a port scan. So basically we can check different ports on the website like this by basically sending like this, and most of them will be closed. I think there's about 67,000 of them. So it's a lot to test manually, but thankfully we have the power of technology. So we can simply push it back here. I'll just clear some of these off so you can see it better. See? Then we can inject our own header here. So we can say something like this, and then we can put down numbers. So basically, if you find a way to send requests to the local host, like I have here, we can enumerate all the ports and see what services are running on them. This is basically, if you remember the diagram, this is us looking at those backend services and seeing which ones we can find. And then once we find them, we can start interacting with them. So let's look for the first 1,000 here. Hopefully I don't crash my server with this. So we're just launching the requests here, and we can probably sort by status code to basically find ones. And let's just give this a minute to go through all of it. Okay, so this is finished now. And let's see, sort by the status code, and we have a few requests coming back to us here. So we have this port 800 request coming back. It seems like it's come back with a environment file. So this is ideally what you want to find. If you can find some kind of IP address or service like this that's just going to leak credentials, you can just report it immediately. And that's really good. It's just really handy as well because it's definite proof that you've got it, so it's going to get triaged fast and stuff like that. As I said though, this metadata stuff is probably going to be secured now. It's going to be hardened, and unless you can send a header as well as a URL, then you probably won't be able to access this metadata anymore. In that case, what else can we do? This is just a false positive, and this is also something. So we found another thing on port 900 here. It says endpoint not found. So we see a JSON response. It's probably an API. So in that case, let's have a look at it in the replay tab as well. Go out to replay tab, send this request. And in this case, if you had an internal API like this and you couldn't find endpoints, what you can do is use a word list to start looking for things you can find. Common things to test for might be something like users, be something like admin, and basically kind of target specific information as well. Like if you have like a project manager, maybe you check for something like projects. And let's just check the users page first. And doesn't seem like there's anything there. User, apps users here. Oh, there you go. And we have found this list of users here. So this API is leaky, and it'll give us back the list of users with their password, which is not good. So kind of a vulnerability you might be able to find here. Again, these backend services, developers are not expecting you to be able to access them. That's why they're generally not going to be secured. Where the main website might get like a pen test like every few months, these services might never be pen tested at all. So the security on them is going to be dubious. And if you manage to find an SSRF like this, where you can read the whole response from like a local host, then you probably will be able to escalate it using some kind of API or using the metadata is here, as you saw previously. So any two of those strategies will work well. And there's a few more URLs you can test for. So there's the AWS metadata URL, which I forgot what it is actually. Yeah, in this case it's 169. It's this thing right here. So if you know your target is using AWS, instead of doing localhost, you can actually straight away test for this. And I don't know even what this came back with, but apparently it actually does exist. Or if your server is using Google Cloud, it's not actually an IP address, but in this case, it's actually a separate endpoint like this. So, oops, here. So if you have this, if you know the target's using Google, you would just tick this like this, and then you would try and find it, right? So again, this is only accessible to basically the local host. So if I went back here and tried to actually access this myself, so like port 800, see that browser won't load. It can't actually find that port. It's not exposed to the internet, right? So basically, that's how you can use SSRF to start leaking data. By the way, if you don't know already, I have labs in the description of my video. They're basically things like this, live examples that you can try out yourself. And they are actually very practical. So here I'm just teaching you the theory side of it. But in bug bounty, you obviously need to do a lot of things yourself. You need to learn how to enumerate things. You need to learn how to basically exfiltrate data and show impact. So that's why I really recommend using labs for that. In each video, I'll include my labs and also a free lab that you can try out, including in this video here, from basically sources like Portswigger. So I highly recommend you to get some practical knowledge in. And if you like my examples, and if you want to basically try out like a lab like this yourself, then you can click the link in the description and try that out. So that's basically how you can extract data using this HTTP protocol. I did also mention the file protocol. So basically, if you can specify HTTP, you can also try in different protocols. So a protocol called file, it's like Gopher, FTP. You can definitely get a lot of payloads on the internet to try out for this as well. So if you do find an SSRF, it's worth looking for that. And in case of the file one, you can just specify whatever we want to here. So I'll try etc hosts in this case. You can see that the server gets back the host in the server, which looks like this for me. And you might be able to get other files, like if you know the server has something else, you can try it out here and look for it like that. So that's how you can try and find files. Yeah, that's kind of it for the main server-side request forgery, where you can see basically the entire response. Now, realistically, if you're hunting in a modern application, chances are you won't be able to see the entire response. Developers will probably have secured that, and like nowadays, obviously security and stuff, there's like basically like automated scanners and stuff like that that pick that kind of thing up. So what's more likely is that you'll find something called blind SSRF, and about half of all server-side request forgery cases are actually blind. What does that mean? Well, it means that you can't actually see the response of the server. So in blind SSRF, you see some kind of indication that the server has reached the port, but it will not return the response to you. So let's see the example here, right? Let's say we went back to example.com, like so, and we see what happened. In this case, the server hasn't responded with the response, but it has told us that it's found it, right? So if I tried something like 2.example.com, it'll say not found because that domain doesn't exist. So let's just go back into this as well, intercept the request here, refresh, and then send it to the repeater. Phenomenal. So what can we do with a blind SSRF? Well, we can basically kind of do the same thing, right? So check if you can hit the actual local host, like so. And in this case, there's no response. But let's say we try one of the previously mentioned domains, right? So it'll say found, right? Let's manage to find our basically the what's it called the metadata here, right? So we know that it exists. So what we can do is something called a port scan. We can basically identify services running on the server. Most of the time, services run on default ports. So the HTTP server will almost always run on port 80. Like a database like Postgres, for example, has its own ports usually assigned to it, and the number is usually the same all the time. So you can actually figure out which services run on which port depending on what the number here is. Or you can at least make a good guess, right? So we can basically get a good idea of what's running on the server by just basically checking which numbers are responsive and which aren't. So we can basically do the same thing as we did last time by sending this to automate and injecting our little payload here, numbers. I would say we'll just start like 500 and finish at 800, right? So when we run it this time, let's see that we're still getting the status code back. So, for example, we have this thing here running, and it's found it. But the rest of these aren't responsive, so we know that those ports aren't open. So that's kind of what you can do with a blind SSRF, and unless you can find a way to exfiltrate data, which you might be able to, you probably will not get a particularly high bounty for this. For a blind SSRF, you're probably going to get like a low, maybe like if you're lucky you can get a medium, right? That's for blind. For like a full SSRF though, if you can pull it off, it's definitely a high or a crit really. If you can get the metadata, it should automatically really be a critical. So basically, you should be looking for full SSRFs. Over half of SSRFs are blind though. The chances are you're probably going to run into one of those, and if you do, you can try and find a way to exfiltrate data. Actually have a lab on that. It's exfiltrating data through regex that you can go try out. And yeah, I think that's all I wanted to cover for server-side request forgery. Oh yeah, one more thing is if your target is a Docker container. So basically modern websites run on something called Docker, which is basically where a small partition of the system is created to host the website, and it basically runs some kind of like custom operating system in there. And it's a little bit safer because it allows basically apps to be like separated from each other. It's kind of part of this microservices thing I was talking about. You should really go watch that video actually. It really helps you understand server-side request forgery. But these Docker containers will be separated from each other, right? And if you manage to get a server-side request forgery on one of them, then usually the local host will actually be the Docker container itself. So to access other services, you might have to use other reserved IP addresses. So something you can actually look for is the Docker socket, right? So the Docker socket basically allows you to create other Docker containers, and a lot of the time it's actually exposed to a Docker container. So if you can use like a file or like use like the file extension to find this Docker socket, you'll basically be able to run code on the server because you can start new containers and execute code, right? So that will basically allow you to achieve RCE. So one of those things to keep in mind is that if you're in a Docker container and you actually know it's a Docker container, then you might be able to look for this Docker socket and basically get an RCE through an SSRF that way. Right, so I hope this video taught you a lot more about this vulnerability type called server-side request forgery. It's definitely one worth looking for because most of the full read SSRFs will give you either a high or most likely a critical vulnerability, which is going to obviously carry a high payout. And if you actually did enjoy the video, then I have a Hacktivity Explain video coming out soon, which is going to cover 2 server-side request forgery vulnerabilities found in real applications. And that will come out this Wednesday, so stay tuned for that. And anyways, I'd like to thank you for watching and happy hunting.